안 하실걸?
그럼 안 해도 되지 않아? 그냥 한 40분 틀어놓고 올려도 모르다 했는지.
저런 양심이.
싫다. 그래도 오늘 아침에 30분 만에 반 정도 했어. 그것도 배기. 이 정도면 이렇게 올리고 싶다 그냥. 근데 레이첼 쌤이 노트백이 안 해도 된다 했잖아.
우리 해야지.
카톡방에 그 뭐지? 성훈이 그 편지 쓴 거, 글 올린 거 있잖아. 그 수업방에. 근데 레이첼이 답한 거 오늘 들었거든, 민치한테. 학생인 거인 줄 알았나 봐. 성훈님이. 아니, 이거 완전 웃기지? 학생인 줄 알았어.
아이고.
왜냐면 여기 같이 듣고 있잖아. 참여하고 있다잖아. 근데 학생인 줄 아신 거야. 정리 안 해도 된대. 정리 안 해도 된대.
안 돼. 문제 좀 줘.
집에 가고 싶어. 나도 집에서 그냥 유튜브로 듣고 싶다.
유튜브를 좀 집중 안 된다.
민재는 유튜브 잘해. 지금 시작했네. 말할 수가 없잖아. 좀 늦게 시작해지고 있어. 뭐거든? 준 거야 이거?
까.
제가 문제 좀 정리할게요. 저 숙제는
영어라고 썼는데. 무슨 이렇게 개인톡 보내가지고 그냥 이제부터 영어로 해라가 내가 얘기했습니다. 근데 왜 네 한국어로 했어?
그때 시간이 없었어.
말 안 듣는데.
아니 근데 그래서 여쭤봤어. 오늘부터 하는 거냐고. 시간 없으면 내일부터 하는 거지. 네.
어디 그렇게 그냥. 아니 나도 이렇게 이거 컨트롤 C 컨트롤 V 하신 거 같은데.
올려주시다. 이은재 내 거 노트북으로 해. 네 걸로 해야
나 배터리 없어.
걔 내 걸로 해서.
내가 배터리 2시간이면 다 달아요.
나도.
노트북 진짜 꾸렸어 진짜.
잠깐만.
노트북 바꿔야 돼.
어디 유튜브 산 거야? 아니 원래 있었나?
아니 안 바꿔요.
뭐
내거 기기가 없어요.
김종호 김 좋아하는데?
밥 먹었냐?
여기 수학 전체 카톡방에다가 링크를
올리신 거 아니에요?
아니 그거 안 올렸었잖아.
방금 그걸로 들은 건데?
먹으면 안 돼.
지우셨대. 또 열어야 되겠네.
먹을 거야.
응?
무슨 소리인지 잘 모르겠는데?
저기 버린 줄 아는 거 아니지? 저기 뜯어서 안 응? 이게 만들어 열어 가면.
아이 뭐요?
그거 우유에다 꽂아놓은 거.
아.
그러니까 그 우유 뭐 꽂아놓은 초코 맛 나.
제가 먹었는데 진짜로.
맛없어 그럼. 먹어봐.
선생님, 준이야 나 어제 민지 좀 있는데 빨리 끝나면 안 돼?
잠깐만.
뭐 잠깐만. 우와 찾아봐라 미친 소리.
왜 그러네?
내가 더. 알걸요?
나 샌드위치 지금 안 갖다 주시니? 따가워. 오.
뭐고? 중앙에 선보이지?
애기랑 했는데.
애?
야
이거 조만간 다 보여 여기.
지금 라이브로 중계되고 있는 거.
저는 열고야 잠깐만. 오늘 노트 빼기는 안 하고
근데 왜 새벽예배 나오냐?
네, 설정이 드신 게 있었나 봐.
뭐가 있더라고.
안 왔어요 여기. 말고 해야지. 왜 종학이만 보냐? 은혜는 왜 안 물어보지?
정확히.
은혜는 왜 안 물어보? 민지 빨리 갔어.
계속 빨고 우리 만난다. 빨고 다시 나졌다 다시.
아니 참석합니다.
그리고 이거는.
아,
정확. 은혜야. 목소리 만들어봤거든 우리가. 근데 너는 그런 질문을 이제 많이 해야 돼. 그러니까 한 가지 모르는 게 있으면 10가지 질문을 해야 돼. 알겠지?
나 머리 하나 모르겠어.
그러니까 질문 이렇게 하는
어.
거야.
헬로.
헬로.
너도 질문할 거야.
다 먹었는데.
나 진짜 되게 잘못했다.
야, 이거 이은혜.
그 뭐라 기억이 안 나구나.
따라서 먹어보면 잘 없어.
나도 질문.
야야야. 이거.
질문
이렇게 쓰네?
좀 무서운데?
목사님께서 조만간 부른다.
이게 또더 무섭잖아.
부르신다고.
초콜릿 나는데.
오케이.
짜라 원이야. 없다.
뭐야.
뭐가 이제 V?
응.
야 이거 보고 춘다. 아 물티탭.
아 근데 그래도 안 할 거야? 저번에도 말하셨는데 안 불러줬잖아.
근데 이번에는
진짜인가 보지.
그러시잖아. 언니 얘기가 드렸잖아.
뭘 얘기하는 거지?
모르고 자기가 얘기하는데.
아나 집에 안 갖고 와서 아무것도 안 갖고 왔다.
왜? 가방만 들고 온 거야?
여기서라도 한 개 찢어서 줄까?
아 종이 넣어가지고. 아집 갔다 왔어야 되는.
설마 필사만 갖고 왔니?
안 갖고 온거 같은데 아무것도 아니 아무것도 안 들었어.
다 원이야.
유튜브밖에 안 가요.
노트북에다 적어.
고체장 가져갈게.
가위 가위 여기 가위 없어?
물어봐 저기 있을 거야?
이거 뭐야?
어디다 그러면 이거는?
어?
시간.
이거
어디 나오고?
그래 먹어 이거?
뭐?
신기하네.
가위 잘라서 수학을 입으세요.
아 이렇게 해놓을까? 아 댓글 보기 이렇게 해놓자.
이제 와.
그리고 잠깐. 그러니까 너가 뭐 얘기하면 되냐면 그 이제 질문을 그러니까 솔직히 말하면 어?
가위.
가위 있어. 솔직히 말해서 모르는 게 많다. 그러니까 끝까지 질문을
네가
하겠다. 이렇게 얘기하는 거.
오늘 술 사는 거 아닌가? 아니 이거 엄마 건가?
내 건데.
어제 샀네 그러면? 아닌가?
작년에 있었어.
아 잘못했네. 아 니가 안 맞는 지 너무 오래돼가지고.
맞아. 몰라 뭐지?
이겠니?
내가 빨간 다시 씻어줬어.
물을 씻으면 녹슬 텐데.
이건 꺼내놓자. 샌드위치 나.
뭐 게임 한다고 했는데?
오늘?
아니 나.
아 게임 안 했으면 좋겠는데.
어? 안 봤어?
오빠
MIT?
시간이 없었어.
MIT 안 봤어?
맞겠니?
너
나도.
나만 봤네.
크로스 하는 거야?
뭐라고 했어?
아그 자막
괜찮아, 뭐
보면
여기서
되잖아.
질문하면 되지 뭐.
자막
아마
보면 돼.
한국어 자막이 안 들어있잖아.
진짜 돼. 그 자동 번역 들어가면 한국어 있잖아.
아 그래 그거 돼?
돼. 내가 얘기했지. 아 내 말 안 했다니.
그러니까 없어 그냥 자막. 헬로.
어이?
What are we going to learn today?
Today we continue. I give you do remember induction proof? I'm gonna prove some fake stuff. You have to tell me what went wrong. And then I have some games and puzzles
Oh.
Oh,
that if you solve it, you get a cookie.
oh yeah.
Okay, so this
Teacher, frankly speaking, you're not understand fully your lecture.
yeah, of
So
course not.
please a little easier.
Yeah.
And
I
we're going to ask many questions to you.
That's good. Ask me. Okay, here's the deal. I just want to give everyone talk because I don't expect you to understand everything.
No.
If you understand everything that you haven't learned yet, there's no point in learning it. Do you understand?
Yeah.
Like, the thing is that if you already know everything, then why do you learn?
So it is normal to not understand that.
Are you kidding me? When I take a course, okay, this is important to understand because like when I take a course in school, I never understand everything the first time. Never. No one does. The thing is that like if you understand everything, you only understand if you already learned it. Like there's gonna be a lot of things that you don't understand. That's just like, and it's not like, it doesn't mean that there's something wrong with you, it just means that it's hard, things, like you haven't learned it, so it's gonna be hard to understand. And that's why, you need to do like a lot of times and, just, if you understand a little bit, that's good. Because now it's like you see it, maybe you don't understand everything. Maybe you understand like even just 20%. Even you just understand 20%. The second time you see it, you'll understand 40%. The third time you see it, you understand 70%. And then by the time like you take a course in this stuff, you understand everything eventually. Or maybe you never understand everything.
So we have to practice and review all the.
You don't have to do anything. This is just like for fun. You're just seeing stuff that you've never seen before. If you see something that you've never seen before, you're not gonna understand it. I'm gonna be honest. Like, I know that you want to understand, but it's very difficult to understand everything the first time that you see it. And it's gonna, like, I don't know, like you're going into high school, right? So compared to middle school, high school will be more like that, a little bit more like this, and then when you go to college, everything will be like this.
So our class is ready for the future?
Yeah, I mean, like, I think it's just a different, like, mentality, because I think in a lot of math classes here, they give you a formula, and then you memorize and you solve the problem.
Yes.
But in the future, if you do, like, in any field, it's not just math, it's not just math, it's not just anything. What's gonna happen is, you're gonna have to figure stuff out. You're gonna have to, like, they're gonna give you a problem that you haven't seen before on the test. So for example, a lot of, like, the classes that I take, we have some lecture, and then you go and you have homework. On the homework is something you've never seen before. It's related to lecture, but you don't know the answer. Sometimes the problem set, it's like 6 problems. It can take 12 hours, 10 hours to do in total. Then you go to the exam, then the exam is more problems that are more similar to the problem set, but maybe you haven't seen the exact problem before. If I were to, like, when we take an exam, we get a formula sheet with all the formulas. And people still, like, it's still difficult. So it's just, I think it's a different way of, like, thinking, because it's more about, like, just to exercise your brain, to try to understand some things that maybe you haven't seen before. You know, like, it's not, how do I explain this? I don't want to be like, I don't want you guys to be hard on yourselves or take it too seriously if you don't understand something. Okay? I want you guys to go easier on yourselves and to say, okay, like, maybe I don't understand this, but think about what you do understand. If you understand anything, that's good. Like, I give you problems and I see you solve the problem and you solve the problem correctly. That's amazing. Like, I think, okay, in my head, you guys are like, oh no, it's so bad, it's too hard, I don't understand things. And then I think, I'm like, wow, they're doing so well. Like, they're doing so well. No, it's like, seriously, that's what I think, is like, you guys are so good. Because I could like, I don't know. So I think that you will do okay. There's some hard things. But some things will be easier, so it's okay. And you know, like, probabilities, so later we can do expected value.
Unexpected value.
So it's related to probability, but it's like, for example, when you play like a game, it's like how you make your decision on how to play the game to the best strategy. So for example, you play poker, like how much should you bet? How much money do you put on it? What's your chance of winning? So that kind of thing.
So it is for the winning game?
Yeah, so like expected amount of return. So if I give you a situation of the game, and then I say, okay, how much money do you expect to make? Or how much money should you bet to make the maximum amount? So what's your best course of action to win?
So more expected, more bets?
More expected is good. You want to get more back. You want to make money.
We are learned in probability at first, and we learned modular and physics.
Modular, you don't need to know modular. I just want to introduce it because you may see it later in math, but you don't need to know that because that field, like, it's called number theory. It's very difficult, so don't worry about that. Like, everybody, like, I remember I took the course, and during that unit, all the college students, they have a hard time. So don't worry.
What is number theory?
That's like modulars and like common divisor. But the only reason I introduced that is because that's like how all of cryptography works. So when you make like a payment through KakaoPay or NaverPay or something online, that's the reason why people can't steal your money.
So it is like security?
Yeah, all of security relies on that kind of math.
So the number theory is more difficult and people can't steal money, or?
Yeah, so the reason why people can't steal money is because most security algorithms rely on factoring like the product of two really big prime numbers. So it's like, you know, prime is the only factors are one in itself, right?
Yes.
So it's actually, as of right now, it's impossible to factor the product of two really big prime numbers fast. Because if you imagine, like, what do you try? If you try like dividing by things, you can't divide by anything until you get to the prime, right? So it's, most of it relies on like that idea. Is that theoretically speaking, if we could factor, so say I have like two really big prime numbers, right? And I multiply them together and I get some other number. If you can factor the product to find the two primes, you could like literally just like steal everybody's money. could do that fast. But it's actually, as of right now, like, I think we think that it's proven to be, well, not proven because, this is hard to explain, but it takes the computer can't do it right now. As of what computers can do at this moment is impossible.
Then how the hacker hack the computer?
That's different. So the hacker, that relies on other things, but this is like crypto. The hackers, as of right now, they can't crack the highest level security of crypto, unless they have like a key. So unless somebody tells them one of the prime numbers, the prime number that they need, because then they can factor. Okay. So that was why I introduced that, because it's like a big deal right now, I guess, or as of like the past couple decades. So like since like the 20, 30 years ago, it's a very big field, but it's very difficult. Like most people, they never understand that. Even like I don't understand fully like the crypto, like the security. I know like on a basic level, like how it works, but I can't fully understand. So yeah. My brother, he took a course in the cryptography, and it was so hard. He was just suffering the whole time. So don't worry about that.
So we learned about how we can prove. So it is related to computer science or math?
Yeah, and math. Like, so when you take a math course in college, basically every math course will have proofs. You won't see any math course without proofs, basically. So this is like how math is. Okay, but I think like there's some things you guys are doing better with. I think like, there's some things you do better with. I expect that the number theory would be hard, so don't worry too much. You don't have to know. You don't have to know any of this. That's my point, is you don't have to know anything. It's just for fun. Like, if you do understand, it's like, oh, wow. Like, genius! Yes, you're a genius. You're a genius. That's what you need to tell yourself. Don't be like, it's too hard, I can't do it. Be like, well, I'm so smart. I can understand some of it. Just a little bit. Is everyone okay with that? Does that make sense? Everyone, like, genius, all genius. So smart. So smart, okay? So smart. Don't worry. You don't need to do any homework. You don't need to study. Just try, Like, when I say to try to do the problem, I don't expect you to solve the problem. I think, maybe they write like one step correctly, maybe two, and then they don't know what to do. So when I give you a problem, I expect that you fail. No offense, but if you don't fail, I'm like, wow, they didn't get it wrong. But the idea is for you to think about it, because normally, like, for when I have a homework problem in classes, if I don't think about it, if someone just tells me the answer without me trying to find it, then I fail the test. Why? Because I didn't try the problem. I didn't find through my own thought process and understanding. Because if someone just gives you the answer, you never learn how to find the answer yourself. And then what if somebody gives you an unsolved problem? So usually in math, there's a lot of problems that no one can solve it yet. And so there's no answer. And then what do you do?
So it is important to think problem on thoughts even if you're failed.
Yes, that's the whole point of math. You're gonna fail like almost 100% of the time. The failing is fine. Failing is something hard and you fail, then you do something easy and you get it right. I'm sorry. I think it's like cultural education difference. But I don't know. Not on a test. Of course on test, like there's no tests. There's no pressure. That's why I do some advanced things, because like obviously if you take a test, then we can't, because it matters. But if there's no pressure, then why not? You don't get to learn this in school. You don't get to learn this anywhere else here, so maybe you like some things, you don't like other things. Then when you go later, you can say, oh, well, I like this, so maybe I'll take a course in this. Or I don't like that, so I can avoid that subject. I can avoid number theory. Okay. So, does everyone understands, do you understand how, induction works? Because you guys did that right last time, actually, a lot. You probably forgot, which is why we're going to go over it again from the beginning. And that's okay, I expect you to forget everything. And then you say, during the moment you understand, and then you go home and you're like, what? What was that? I don't understand anything anymore. I'm the same way, same. But you will understand, the more you think, the more you understand. So the idea is basically, it's like a small, you have the base, the small n, right? And it's like dominoes, dominoes? The little dominoes, and they're in line with each other, right? Okay, I can't draw, but you know what I'm talking about. Domino, and you knock it and they all fall. So that's how you think about induction, is you show, okay, I can knock the first one, and then you show that if I knock the first one, the rest of them all fall down, even if it's an infinite number. So it's it keeps going until they all fall. Okay. So that's the idea. The idea is to knock the stack of dominoes over. Okay?
But can't we prove about big one to impulse about small one?
So here's the problem with that. Say I start with a big one. Then I'm only proving that, so say I start with 50, right? N equals 50. Then I prove n implies n plus 1. I've only proved that this works for 50 and up. Then what about 1 to 49? Because I've only proved it for n greater than or equal to 50. That n implies n plus 1.
If we improve about n to impulse n minus 1, so
but then if n implies n minus 1, then it's only going, that means that it's going this way, right?
yes.
And then what about everything bigger than n? What about everything above whatever you started as n?
So we are usually, last time class, our small number is 1.
Sometimes. Sometimes 0, sometimes 1, sometimes 2, sometimes you have multiple
It
cases.
can be 0 too.
Yeah, it depends on the problem. Because you have to look at the smallest case for the problem. Okay? So it's just the smallest n in problem. So it depends on the range of n, right? So if n is in, 0, 1, 2, it could be in that. It could be n in even numbers, 2, 4, 6, 8. And then you would prove that n implies n plus 2. Right?
And then we have to prove that n implies n plus 1. Why we should prove n plus 1?
Why? Okay. That's the domino idea. So you want to prove if I knock this domino over, this one falls.
Mm.
If I choose this one falls. It's like, here, okay. So it's like here, I have all my cases, right? So let's say I start with 1. We know that this one, the statement is true. So for example, we had the sum of the odd numbers, right? So 1 plus 3 plus 5 plus 7 plus 9 plus, right? And it's actually the sum is n squared. So, right, we have, okay, 1, 4, 9, 16, 25, right?
Yes.
So it's actually n squared. Okay, so I say, okay, what's 1? 1 is 1 squared. So this case is good. Then I want to say I take literally any n, that if this one is true, the next case is also true. The next case is also true. So like this, so it's like saying, say n equals 1. If n implies n plus 1, then this would have to be 2 squared. This would have to be 3 squared, because then your next n would be 2, right? This would have to be 4 squared. It's like, okay. It's like each one of these is a domino. And if the domino falls, it's n squared. And so you're proving that if I pick any number in this sequence, any number, right? And say this one is n squared, right? Say the value is n squared, if I add it. Then I look at the next one, and then the value will be n plus 1 squared. If the value is n plus, you need this to happen when I add this number. So if I take number n, right? So I take number 7, right? What's the value at that?
7 squared.
So 4 squared, because it's the 4th number, right? So it's 16, right? Which equals 4 squared.
Yes.
Alright, now I look at the next case. What's the next number?
9.
Yeah, 9. Okay, we know that this is 16. Okay, and that's 4 squared. Then we say, okay, we need to show that 16 plus 9 equals 5 squared.
Oh.
Which is true.
Yes.
Yeah, so we're good. But so what we're doing is instead of taking an actual number, we're saying n is an arbitrary number. Any one of these numbers could be n. Any one in the entire sequence. Okay?
So we have to prove n plus 1 because the number is unlimited.
Yeah, the number is unlimited. So you just say, okay, let's say that n is the 10,000th number in the sequence. If we know that we know that 1 is true, and we know that if n is true, implies n plus 1 is true, then what's true about the 10,001st number?
It's true.
Yeah. What's true about the 10,002nd, if this one's true?
It is true too.
Yeah, what's true about the 10,003rd, if this one's true?
Yes.
True.
Yep.
Mm.
And so on. Do you get it? Like, the idea?
Yeah.
See? Genius! 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 Okay, genius. Okay, so that's just the idea, right? It's like a chain reaction. Chain, like, I knock the dominoes over and they all fall infinitely until the end, like until infinity. basically. But why can't we do it without the first one working? So if n equals 1, so n equals 1 is our first one. What if n equals 1, that one's false?
The 2 and 3 and 4 is a force.
Well, we don't know.
Because we don't have information the next one.
Yes, we don't know. It doesn't tell us anything.
It could be true and it could be wrong.
Yeah, we don't know.
We proof again.
Yeah, it doesn't work. It's just we don't know, so we can't do anything with our proof. We just don't know anything. Okay. Questions, ask.
That's like a force implied force is true.
Yeah, so it's like, we don't know, it could be true, but there's nothing that we can solve because, okay, say that we show n implies n plus 1, but if we don't have some place to start, then we don't know anything. Because n plus, it could be true, it could be false. On, n plus 1, it doesn't matter, we don't know what it is.
And the why we choose that is true, it could be wrong and it could be true, but why we say it's true?
Because n could imply n plus 1.
Yeah.
But what we're talking about here is the value of n plus 1. So we say, okay, n is false, right? N equals 1 is false. You don't need to understand this that well. This is hard, so I don't expect you to understand this. Okay? Just clarifying. But then what if n plus 1 is true? It could be true. It could be false. All we know is that n implies n plus 1, but we don't know what the value of n plus 1 is.
But people usually said the force implies force is true. Why the first one can't imply and can't add information to the second one, but why we choose say that is true?
It's okay. So the thing that we're saying is true is that n implies n plus 1. This whole statement, this entire statement is true. Whether it doesn't, so say the value of n itself is false. We've just shown that n is false and this is true, but what's n plus 1? We don't know. This is really hard, guys. This is really hard. But basically, think about the n equals like the base case being true as the first domino. If you don't knock the first domino over, do all the dominoes fall? Exactly. So just think of it as you need to knock the first domino. Otherwise, none of them will fall. You don't know anything. Okay? You understand a little bit? Okay.
Can't we assume that n is minus number?
Well, it depends on the problem. It might get kind of messy, though. Generally, I won't give you any problems where n can be minus number. But usually, like when you're doing induction, it's usually going to start from 0 or 1. Because there's some problems, it could be game. you could be playing a game and then you would induct on which move in the game it is. So say I make a move, they make a move, I make a move, they make a move in a game, you know? And then the number, the n would be which turn it is. Who makes a move. The number of moves made. Or it could be, you know, a number, like, you know, just a number. Any number, like in terms of like odd numbers, n could be the odd numbers.
So usually n is integer?
Yeah, usually, yeah.
Mm.
Some sort of, yeah. So for example, we had, you know, 1 plus 2 plus 3 plus 4 plus 5 plus, right? And then you can prove that. Do you want to try?
Yes.
Yeah, you can do it. You did it last time, so you can do it. But I expect you
Wrong.
to do a little better. You know, maybe you get the base case, and then you mess up in the inductive step. But that's okay.
So proof now?
Yeah, just try.
Okay.
You don't have to do it right. You can try. Okay. So that's what you want to prove, right? So it's like the domino. So what's the first thing you do?
How
Okay.
can we write with the sum?
Yeah, you can write with the sum. So the sum, this is just a symbol, okay? This means everything inside is plus.
I mean is inside?
So this means like this would be 1 plus 2 plus 3. Because I is ranging from 1 to n, right?
Mm.
This is the biggest I, and this is the smallest. You can see it as the biggest is at the top, right? You'll probably see this in high school. You'll see this in high school before college. So this will come soon, okay? So it's like this is the big one is on top because it beats the small one. Okay? And then it's just I, which is just the numbers, right? And then this means sum. Don't worry about it. Don't worry about it. So you know what this means, right? Okay, yeah. So it's like the first thing you want to do is you want to think, all right, what's the first domino? We have the dominoes, you know, lined up
Yes.
and knock over. So what's the first one? N equals 1. Okay. N equals 1.
Yes.
What's the sum of 1 plus up to n? This is just n. So what's 1? 1 equals n equals 1. Okay. Now, is this true? So what is this value? 1 times 1 plus 1 divided by 2 equals?
Equals 1.
Oh! Which was the sum of all this. So, right, it's true. Yeah.
What was the next step of the base case?
So that's it for this. So that's your base case. That's the first domino. Right? right? So now what we need to show, so this is domino number 1. Now we need to show that if we knock this one over, the rest of them fall. How do we do that?
Add this one next of the base case.
Now it's the inductive step, but you don't, what that means is just, okay, let's say the nth domino fell. Okay? Now I want you to say that n plus first domino falls. So we show the nth domino knocks over the n plus first one. So let's look at n. This is just some nth domino, right? And then we have n plus 1. Right? We show that this guy knocks this one over. Okay? Alright. So the nth one fell. What does that mean? That means 1 plus 2 plus 3 plus what? Yep. Equals? Yeah, that. Okay?
Okay.
So now we look at the n plus first. What do we do? Well, here we stopped at n, but so we have the sum of the first n numbers. So if n equals 100, it would be 1 plus 2 plus 3 plus 100. N equals 101. 1 plus 2 plus 3 plus 100 plus 101. Okay. That was adding 1 to n, right? Alright, so we have n. What do we do with n plus 1?
어디가 알아?
Alright. So, if n is 100, n plus 1 is 101. What did we do? This is the same, right?
Yes.
Then we added n plus 1. So, if we look at the n plus 1 case, we have 1 plus 2 plus 3 plus n plus, yes. Okay, and this is equal to this plus, so what's this equal to? And then what do we have here? Okay, agreed? Okay, and we want this to look like what? So, if we put in n plus 1, what do we get? N plus 1 instead of n. So this goes to n plus 1, right? And this goes to plus 1 divided by 2, which equals?
n plus 1 times n plus 2.
Alright, and we want these two need to be the same. So this is just algebra now. So this is just easy math now. So let's see. Let me take this. Okay. So this is equal to n squared plus 3n plus 2 divided by 2. Okay. And this is equal to times, we multiply by this times 2 over 2. So this is equal to n times, so n squared plus 1 over 2. N squared plus n. Yes. Good catch. I make mistakes sometimes. Plus 2n plus 2 over 2. What is this?
n squared plus 3n plus 2.
Aha. Huh. So, what does this mean?
P implies P of n plus 1.
Yeah, it means domino number n knocked over domino number n plus 1. Why? Because when we add n plus 1 to n, if n falls and we add n plus 1, we get the same formula. Does you understand just a little?
Little.
That's okay. That's good. That's good. That's good. A little bit. Okay. So, the goal with this was to show that, 1 plus 2 plus 3 plus 4 plus 5 plus n, where n can be like infinity, goes to infinity, right? Keeps going. Equals n times n plus 1 over 2, right? So the case was 1, n equals 1. This is good, right? This domino went over.
Yes.
Alright. Let's assume this. Let's look at n plus 1. Right? So, ideally, what do we want? We want 1 plus 2 plus 3 plus 4 plus 5 plus n plus 1 equals n plus 1 times n plus 2 over 2. Right? Alright. What we did is we took this and we said n times n plus 1 over 2 is equal to this. That means the nth domino fell. Domino number n falls. Okay, we just add plus n plus 1. And we solved what that was. And it turns out that this was equal to that.
So there was many ways to prove formula.
This is the easiest way to prove this formula. Because you've probably seen this before. Right? You've seen this. So for example, 1 plus 2 plus 3 plus 4 plus 5 equals? So, yeah, 15, right?
Yeah.
2. Okay. And what is 5 times 6 divided by 2?
50.
See? Okay, now you add, so it's right?
Yes.
So 1 plus 2 plus 3 plus 4? 10. And what's 4 times 5 divided by 2?
10.
So we found the formula. We know that it's true. We think it's true. But I want to convince me that it's actually true. And this is the easiest way to prove that the formula is true. Instead of just saying, oh, that's funny, it seems to be true. For example, if I add 15 plus 6 equals 21. What's 6 times 7 over 2?
21.
Yeah. So you say, seems to be working. But then how do we actually prove that it's always true? And so we have to take an arbitrary n. Because what if n, say n is equal to 100,201. How are we going to add up 1 plus 2 plus 3 4 plus... No, we don't want to do that, right? It's too hard. It's much easier to say 102, right? But how do we know that this is true for such a big number? Because we take n going to big. That's how we know that this is correct. Even for such a big number. Okay?
If you don't know the base case, what happens?
None of it works.
Some people then said that if the base case is a smallest number, so they can ignore that and go to the next step. Or they
Sometimes you need 2 base cases. There are cases where you need 2, because what you have to check is that the base case and that implies the case after. So actually I'm going to show you right now a false proof. So I show you a proof by induction, and it's going to prove something completely wrong, and the reason why is the base case. Okay? So I'm going to prove... You're going to believe it too. You're going to think I'm right. Okay. Sorry. Okay. So,
it's like a 2 plus 2 equal 5.
yeah, like that kind of thing. Okay. Alright. So, let's see. Which one should I do first? Alright. Let's see. Alright. For n in okay, so n is something, n is a number, a non-negative integer. N is, 0, 1, 2, 3, 4. Alright, theorem. This is just, I'm telling you this is true. It's not true, but I'm telling you it's true. 5 times n equals 0. Yeah, so it doesn't look right, right? Proof.
How can you prove that?
I'm gonna prove it by induction.
Oh.
Yeah. Alright. Inductive hypothesis. 5 times n equals 0. Alright. Base case.
Oh.
Oh.
5 times 0 equals 0.
Mm-hmm.
It is
Yay.
weird. What?
Inductive again. Alright, I promise you, you're gonna be convinced. Alright. For 0 less than or equal to j, less than or equal to k, let, or less than or equal to n, let's say n, let n plus 1 equal I plus j, so that
What is I?
just some number. So I and j are in this range. Okay? They're just some numbers. Just some numbers that are less than, or equal to n. Okay?
Why we assume that j and I is between 0 and n?
Because we're saying that for this, 5 times n equals 0. Okay? We're assuming it for n. Now I show you n plus 1. So the base case is right, right?
Yes.
No.
The base case is correct. 5 times 0 is 0.
You have to consider the n is 1.
Wait for it. You know, but wait for it. See, it's like magic. Okay. 5 times n equals 0. Okay? N plus 1 equals I plus j, right? You can write n plus 1 is the sum of two numbers, less than n. It could be n plus 1, n minus 1 plus 2. I and j is anything in this range. That sum to n plus 1. Okay. So, 5 times n plus 1 equals 5 times I plus j equals 5I plus 5j equals 0 plus 0 equals 0. Oh, so 5 times n equals 0 implies 5 times n plus 1 equals 0. So that means 5 times n is 0 for all n.
What?
End of proof.
No.
Okay, what went wrong here? But you agree with me that the steps, they all seem right, Doesn't it? It looks right.
Base case is wrong.
Yeah, okay, what's wrong with this?
Because you have to consider another number because always when we times 0 is 0, so we have to consider other number.
Yeah, because if we were to look, we use two different numbers here, right? We use I and j, right? But when we take the n plus 1 case, even if 5n equals 0, 5 times 1 equals 5, which is not 0. So when we look at I and j, we would need at least two base cases. And so if we were to look at the n equals 1, what's 5 times 1?
5.
What? A 5.
And that's not 0. Okay, right? You need to be careful. Alright, does everyone understand why this is wrong? Because you can prove a lot of amazing things with induction if you're not careful. Yes.
n plus 1 equal 1 I plus j.
Ah, so I just decided to do that so that my proof worked out. So, okay. So why can I do this? Why is that okay? If I and j, so you know that j is less than or equal to n, and I is less than or equal to n, right? So there, say I plus j can equal n plus 1 if we just let them equal it. So for example, I equals 1, j equals n, I equals 2, j equals n minus 1, I equals 3, j equals n minus 2. Okay, yeah, you can just say that they are any numbers that add to n plus 1. Okay?
The base case is wrong, so it's lead to that the conclusion is wrong.
Yeah. So the reason why this doesn't work is mainly because of this. Why?
It's a true number, so
But we only assumed 1 here in the base case.
in that case we have to prove the base case and is 1.
Okay, yeah, so if we were to do this, say n equals 0, n plus 1 equals 1. Can we do this? Is it possible?
No,
Why?
because there is two numbers, but n is
So in order to do this proof, we would need a second base case, and we would need 5 times 1 equals 0. But this is not good. You don't need to fully understand this. I just thought it would be funny. Because it looks right, you know, it looks like reasonable. But not exactly. Please ask more questions. Ask more questions.
So when you figure out the base case, we should n is 0 or 1, both.
Yeah, so your base case depends on what you're doing in the next step. So for example, the first step of this, the inductive step, should be your base case. First of all, n equals 0 is true, should imply n equals 1 is true. But this is not true. So if n equals 0 is true, 5 times 0 equals 0, right?
Yes.
That's true. What's 5 times 1?
5.
That's not 0. So this is false. So, because it's true that if both of these are true, that n implies n plus 1. We showed that. But the problem is that the first n doesn't even imply the second n. You know, so it's like n equals 0 doesn't even imply. So it's like the first domino, so the 0 is the first domino, right?
Yes.
The first domino fell, but the second domino was over here. And the second domino, that's 1, it didn't even fall when the first one fell. So it's true that if the first one knocked over the second one, then the rest of them could go, right? But this didn't even happen. So the whole thing is wrong.
question demands us that the odd number, you have to prove n is 1 and is 3.
No, you know why? Because when I'm asking about odd numbers, the sum of the odd numbers, right? We're only adding one number each time. So it doesn't matter, right? So if it's true for 1, that the sum is n squared, right? Now say if I were to say for n is odd, 5 times n equals 0. Well, you're lost at number 1 because 5 times 1 is not 0. For n is even, 5 times n equals 0. Well, you could do the same thing. You could have the 0.
0 is even number.
Yeah. Why? Because 0 divided by 2 is 0. 0 is divisible by 2. 0 is considered an even number. So 0 and you would need to do 2. Yeah. This is a little bit hard. I'm sorry. But I thought it's pretty funny.
Let's prove another theorem. It's wrong.
You want to do another?
Yes.
I have more. I think it's pretty funny. You don't need to take notes, guys. Like, honestly, don't even worry. Everyone's so studious here. It's so funny. Like, in America, when you have kids in the classroom, they're just like, oh, okay. No one's like, everyone here is like this, and then in the US, it's like, everyone's just like, when is this gonna end? Not in college, but like in high school, middle school. Okay, so we do another proof. Or fake proof, I guess. Okay. This is a similar one. I have about 2 more. So, alright. A to the n theorem. A to the n equals 1 for n equals 1, 2, 3, 4, 5. And a is a real number. Do you know what a real number is?
Not
Not
imaginary.
imaginary. Okay, so a can be anything. So, you know, a could be 3 halves. 3 halves, 10/3, etc. It could be anything. Or even, you know, 5. Okay. Alright. So, let's see. Here's our base case. N equals 0. A to the 0 equals 1. Okay. Inductive step. Assume a to the n equals 1 for all n in, you know, all n up to n. Okay? Now, we write this as a to the n times a to the n divided by a to the n minus 1. What's a to the n divided by a to the n minus 1?
I don't know.
Okay. Right? Okay, what's
Oh.
you know this, right? So a to the 5 divided by a to the 4,
A1.
Yeah.
아.
Yeah. a to the 5 minus 4. Okay?
Okay.
So when you divide powers, it's minus, and when you multiply, it's plus, right? So what's a to the 5 times a to the 4?
A to the 9.
Yeah. Okay? You know this. Yeah. You learned this. Okay. So, what's this? Oh, sorry. What's this?
N minus 1.
A to the.
아,
A
아니,
to
아니,
the
먼저.
1.
원.
아,
Okay. What's a to the 1 times a to the n? A to the n plus 1. Okay, yeah. Okay. So, what's true? What is a to the n equal to? So we know that this is equal to a to the n times a to the n divided by a to the n minus 1. Okay, that equals 1 times 1 divided by 1. Right? Because a to the n is 1 for everything. Okay? And that's 1. End of proof. Why is this wrong? Magic.
Y A to the n plus 1 is 1.
우와.
아,
Because A to the 1 is not 0.
There's that, but also the main issue is with that. What's our smallest n?
0.
Yeah.
It can't be a n to the minus 1.
We don't know what this is. Exactly. We don't know what this is. Because what if n equals minus 1? Or what if n equals 0? What's n minus 1? But we haven't assumed this for minus 1. Minus 1 is not in our base case. So we can't write it like this. It's wrong. Right?
Y, in base case, Y, A, 0 equal 1.
Because 0 is our smallest n. Oh, by definition. Do you not know this? So anything to the 0 is 1. What's 5 to the 0?
1.
What's 10 to the 0?
1.
What's 1,000 to the 0 power? Or 10,000 to the 0 power?
1.
But 10 power 1 is
10 to the 0 power.
음.
Anything to the 0 is 1.
really?
Yes, you need to know this. This is definition. Okay? Yes.
Okay.
Right? You know this, right? Yeah, he knows.
나 몰라지?
Okay. anything. So if n is a number, like if n is real, n to the 0 equals 1. Always.
Only if the n to the negative number, how can this the number exist?
Yeah, n to the minus 1 equals 1 over n, right?
Really? I really didn't know that.
What? Okay, alright. You need to know this. Alright. This is stuff that you need to know. So n to the minus n equals 1 over n to the n.
This definition?
Yeah. That's how it's defined as negative
If
power.
the n to the minus 2, it can be
N to the minus 2 is what?
1 over n to the 2.
Yes.
Oh.
N to the minus 10?
1 over n to the 10.
Yeah.
Mm.
What is 5 to the minus 3?
1 over 5 to the 3.
Which is?
125.
Yeah.
But why we can power minus number is like that?
That's just how it's defined.
Yeah.
Because, okay, if you think about it, like, usually when we write something to the minus 1, so n to the minus 1 means equals n inverse, right? And what is an inverse?
And yeah, 1 divided.
So you just write 1 over n equals n to the minus 1, right? So then, the way that I like to think about it is like, what do you normally do? So 1 equals n to the 0, right? So how can we write n to the minus 1? N to the 0 divided by n to the 1 equals
1 over n to the
and 0 minus 1
n power minus 1.
Okay, what's n to the minus 10? So n to the minus 10. So we want to write it as n to the 0 is 1. This is important. Everybody should understand this. This is like something that I expect you to understand. You should know this.
What are they doing?
What?
There's a question.
Yay! I'm so happy! I'm so happy! Oh no.
He said why the n power to the n power minus 1 is n 1 divided n.
Yeah. Okay. So, why is that? Everyone, n to the 0 equals 1, right?
Yes.
N to the 0 is 1. So, n to the minus 1 equals n to the 0 times, n to the 0, parentheses minus 1.
Yeah.
Minus 1 equals 0 minus 1. Yeah. Equals n to the 0 divided by n to the 1.
Yeah.
Equals 1 over n.
But I don't know why second part and next part relate.
What is n to the a minus b?
원래 그런 거야?
Yes.
음.
Oh.
그랬나?
else be?
N power A times N power B.
이해했어 이제?
오케이.
오케이.
Want an example? Okay. Alright. What's 5 to the 2 times 5 to the 3?
5 to the 5.
Yes.
Alright, let's confirm. Okay? What's this? 25 times 125 equals
5 to the 5.
No, let's do it out. Let's convince you. Alright, so what's 20 times this? That's 2,500 plus 5 times this is 1,250 divided by 2. 675, yeah.
What? 왜?
Oh no, 625. Yep. Alright. What's that? Alright. And is this 5 to the 5?
Maybe.
Alright. Well, 5 times 5 times 5 times
Oh my
5
god.
times 5. Wait, no. What's this?
175.
What's this?
75. Same.
뭐 물어봤어?
Alright. What is 5 squared divided by 5 cubed?
1 over 5. 1/5. One over 2 square.
1 over 2 squared?
5 square. One over 25.
This is?
5 times 5.
Yeah, 1 over 5 times 5. Yeah? So that's 5 to the 0 divided by 5 squared.
Wow.
Because 0 minus 2 equals 0.
Equal minus 2.
Minus
0
not
minus 2
zero.
is
Oh,
0.
wow! Thank you. See, I write this here and then I'm like, yeah, it's 0. That looks like my proof over there. It's like, okay. Okay. Questions. So, n to the minus a equals n to the 0 minus a, right?
Yes.
Which is n to the 0 divided by n to the a, 1 over n to the a. Okay. Does everyone know what this is?
What? I I
my
just-
God. Do you not know this either?
그걸로는 안 돼.
So,
I think it is.
we teach all of this. You learn all of this. You need to know this. Okay? This is very... So, n to the minus a equals 1 over n to the a. Alright. Alright. Okay. So, what about n to the 1 over a? Alright, let's think about it.
I think n over 8.
Okay. So, what's n to the 1 half?
N over 2.
No, it's in the exponent, right? So, what's n to the ab?
N to the A 가로치고 B.
Yeah, yeah.
What we call that?
N to the a to the b.
To B.
Okay. Alright. And n to the a divided by b equals n to the 1 over b to the a, right?
Which is
Okay, everyone agrees?
okay.
And this is defined as,
What's that?
okay, everyone knows square root, right?
6?
That's b, sorry.
Oh, it's B there.
Okay, so, everyone knows this, right?
What is that?
What's this?
We know only scale. Why do you
Oh, okay, I usually write the number. What's this?
2.
Alright, what's this?
I don't know.
what? 그냥 이거 앞에 붙인 거구나.
2
That's
power 5?
Scale 72.
2?
Okay, so, right? So 2 squared equals 4.
Yes.
Square root, this is, I can write a 2 here, right? Of 4 equals 2. 2 cubed equals 8, right?
Yes.
The cube root of 8 equals 2. It's just the same thing, you know, this is like 2, it's finding the reverse operation. So this is equivalent.
Okay.
So, 2 to the n equals k. The nth root of k equals 2. So, I can't believe.
Okay.
Sorry, I thought you knew this. The cube root of 27 is what?
3.
Yeah. There's a funny story about this because my brother, like he's my older brother, when he was in kindergarten, so you know kindergarten, like, 6 years old, 5 years old, 5 years old, my dad, he would do math like this with us, right? So we knew this,
Wow.
like 5 years old, right? And so the music during class, one of the teachers, he was trying to get the kids to be quiet. 너무 시끄러워서 그냥 what's 2 plus 2? And the kids are like 4. What's 3 plus 3? 6. And then he's like, what's the cube root of 27? And my brother goes, it's the only one, 3. And the teacher was like, what? He was like, who is this kid? So it's actually a funny thing. Okay, what's this?
4.
Why?
4 power 4 is 64.
Okay. Have you seen this before?
What is it?
G
이름은 통나무.
뭐야? G 뭐야?
네?
G?
Log.
하여튼 심하고 G.
Log?
Okay, so this just means, okay, so write this down. Log base A of B equals C means B equals A to the C.
Oh my god.
이런 식이 되게
What does log mean?
It's just, we make it up so in computer science, actually, we'll see a lot of, usually in computer science, it's log base 2, right? So the base here, this is the thing that's going to the power. So log base 2 of 16 is what?
Two?
아, 4.
Four? Why?
응?
Because
That's
2
all.
to the 4 equals 16. What is log base 2 of 128? I'm sorry. I didn't know that you guys didn't know this.
7.
Yes. Why?
2 power 7 is 120.
What's log base 10 of 10,000? Easy.
No.
100.
10?
No? Okay. What's 10 squared?
100.
What's 100 squared?
10,000.
So these are basically all just different ways of, writing exponents. Okay? Are you okay? You'll see this in school, for sure. I'm 100% sure that you will see all of this in school soon.
In high school?
Yeah. You should have. I saw this in middle school.
네?
So yeah, I learned it in standard middle school, not on the side.
Oh.
I think
우리 안
junior
배웠는데.
school.
No. I was not in. No. I was in public school. You learn this like first thing that you learn in high school. This will be very soon. All of this. it maybe I would expect in middle school, but I guess in the beginning of high school. Maybe. There's a lot, you use this kind of stuff a lot in every field, chemistry, physics, you know, every science, not just math, but also science. All of it, this. And especially in computer science, it's everything is basically log-based too. Okay?
Why two?
That's hard to explain, but it's basically because in computer science, here, wait. We have a lot of trees, right? So we'll have something like this, right? Where it's like a binary tree, right?
Base root.
Yeah, there's a root. This is just why it's log-based too, right? And it keeps going. You don't need to understand this just because they asked. It keeps going, right?
Yes.
What is the height of this tree?
We don't know.
If there's n, so say there's n total dots. Right? On the bottom. The height of the tree is actually log-based too of n. And so don't even think about this. But usually this represents the course that a computer would take, right? In making, so computer makes decisions, right? And the computer will make a certain amount of decisions and then end up at a certain output, right? And then this is the amount of time that the computer takes because it's the number of steps. You don't need to know this. You don't need to know this just because he asked. Don't worry about this. This is very advanced. Okay? But that's why it's log-based too a lot in computer science. Because usually the computer is making yes or no decisions. Okay. Alright. So, does everyone have like a phone or a computer? Does
Computer.
anyone have a computer or a phone?
Computer.
Okay. I'm gonna send a puzzle. Okay?
Puzzle.
Yeah,
Wow.
a puzzle, a game.
Oh, yeah.
Yeah, because I wanted to do this today because I brought the cookies. And if you solve it, you get a cookie.
Wow.
So I want to give you the puzzle.
No?
Yeah, I sent
No?
it. It's online. Is that okay?
물론이든
Okay. Do you have questions about this?
없는데.
Okay.
Ask questions if you need.
Alright.
Yeah.
I think that it is a first three, not four.
Huh? What?
Ah, he's right.
Yeah, yes.
The third root of 64 is 4.
Yeah.
Yeah, sorry.
오.
Yes! Good. If I'm wrong, you tell me I'm wrong. Good job.
너무 자연스럽게 너무.
Good. That's better. You need to do that. I make dumb mistakes all the time. Okay. Here is the game. So I send it to the cow chat. Is that okay? Rachel, who is the Rachel? Okay. Let me draw the puzzle. Okay.
오, 나 이거 진짜 못하는데.
와우. 아이고.
배드럭키. 배드럭키여서 안 돼. 손도.
Okay. So,
이거 숫자 다 각각 먹는 건가?
응.
그 막 그림 맞추는 거 그런 비슷한 거 아니야?
그냥 이거 있잖아, 이렇게 움직여가지고 한 칸만 들어 있고.
맞아.
반에서 꼴찌였는데.
okay. The goal, how you win is to make this into reverse, which is this was a popular puzzle in late 1800s in American newspaper.
1800?
Yeah, they put this in the newspaper.
19th century?
Yeah, 1880s.
18? 18?
Yeah, like a long time ago they put this in the newspaper.
나 맞아, 18걸.
What did I miss?
11.
Ah!
Oh my god.
See, I'm not genius, I'm stupid.
미치겠어.
I can't even do like 4.
It has many ways to solve this problem.
Try.
게임 스타트.
So the moves you can make,
How we can
you can move any tile, like you could move, if this is the blank, you can move this one down and this one to the right.
야 민재 그거 어떻게 갔냐?
그냥 말 못해.
어?
Try the 15.
어디?
Yeah, you can
네,
only
아래
move
내려가.
into a
아래
blank
내려. 아래
slot.
내려가 이렇게.
So go
여기
down.
저거 아래고
아.
파란색 때.
이게 막 뭐가 있는 거지?
오 와우.
Oh no,
이거
no, it needs to be in the right order. Why did it send it like that? In mine it has it,
아까 여기도 여기 들어갔던데.
so it needs to be in the right order. So if you go down, yeah.
아니지.
So you can reset it, yeah.
그렇게.
Why is this right order?
The order matters.
이게 뭐야 이게? 얘는 좀 빼고는 안 섞여.
Okay.
두번 섞였잖아. 아하.
순서 섞여 있는 거잖아.
아 순대가 섞여 있는 것만 색깔이 젖어 있나 봐.
So
Yeah.
this is and we should make that first
Yeah,
picture.
you need to make that. Like you need to take.
나는 빠져 있어.
It should, okay, ideally it should, mine, when I went to this, mine looks like this.
근데 어떻게 해?
So it should be in order.
You think?
이게 워낙 많은 거.
Yeah, that one, do that one.
그럼 막 하는 거지.
So, no, don't do that. Just keep it like this and click on the next.
아나 이래가지고 그거.
No, don't mix. Reset. Yeah, and then click next to it. Like click 15 and then click. Yeah, yeah.
와.
준이가 지금 저거. 이렇게 만들라는 거야? 어떻게 만들어?
Wait, go back to the previous page.
아 잠깐.
Yeah, go back to the previous.
어떻게 움직여?
I want you to do
You have to make a second
reset. Press
picture.
reset.
Oh,
Do this one.
that one?
Yeah.
Very small.
You can zoom.
오
in.
마이 갓.
And mix.
No, don't mix.
믹스하지 말래.
I want you
여기서
to
뭐야?
go from this to this.
We click help.
이거.
Try.
이거 어떻게 하는 건데?
야 윤재, 그래서 여기서 뭘 만들라는 거야?
That second picture.
It
Second?
needs to go from this to this.
Oh my god.
Impossible?
안 움직이는데 이거? 눌러. 눌러.
How can you do that?
아니 이거 15를 먼저 여기로 옮겨야지. 그럼 여기를 이렇게 올라가는 거죠. 아니 이거 다시 요거를 옮겨.
이렇게.
아니 옆으로 계속 못 가잖아. 그렇게.
Why don't you move them around?
이렇게 하고.
See what you should do.
What is
이제
it?
순서로 옮겨야 되겠지? 십자를
한번 올라오네.
여기 끝에 누르면 한 번 봐봐. 우리가 손 움직이는데 한 개씩 한 개씩 움직이는.
그런 거.
그럼 여기서
오
이렇게
마이
이렇게 내리고 이렇게 하고. 아니 왜? 이거 옮겨야 돼.
이렇게 되면
아이고.
이제 13.
Good job.
원래 한 개씩 하는 거야.
They're doing so well, guys. You guys step it
옛날에
up.
살짝 그 밀어내는
이제 여기 있는 거
아.
내리고.
오케이.
12.
Oh, perfect.
굿. 잠깐만.
How can you do that?
아니 이거 옆으로 가봐. 이거 옆으로 가서. 아니 여기 6까지. 여기 5를 올려. 7을 내려.
Why?
일단 이거 내려.
Mhm.
잠깐만. 이거 에어컨이랑 비슷한 거야. 잠깐만. 가만히 있어.
13을 여기로 보낼까?
아니 13 이렇게 이거 봐.
그냥.
12 내리고 13을 내리고 13 옆으로 하고 올려봐. 그다음에 옆으로 올리고 여기 올려. 그다음에 옆을 옆으로 내리고. 잠깐만.
오 마이 갓.
Okay.
이럴 때는 다른 거 여기 있는 거 옮겨야 돼. 이럴 때는.
안돼. 아까워.
아니 3 올려봐. 한 13. 아니 뭐 하는 거야? 네. 내리고 그냥 여기 그거 비워야 되는데 여기 있는 거. 내가.
이렇게 나와요.
오케이. 근데 어떻게 하는 거야?
Please, can I go to the toilet? Thank you.
Okay. How's it going?
We have to this out.
Mhm.
그냥 올려.
오케이. 됐어. 오케이.
Hey. Woo.
여기.
Oh, you guys are doing so well.
이거 뭐 좀 되잖아. 잊지 말고. 아니 나 이거 생각.
오케이 하고 있어.
Wow.
Rachel, this is dry perm serum. It is present for
Eat.
yes.
같이 먹으래.
I bring cookies. Also, for when you solve the puzzle.
Oh. Oh, they're so good.
그러니까. 됐다. 거의 다 됐다. 나이스.
아니냐?
야 한 개 거의 다 있어.
네.
됐어. 야 됐어. 역시 난 천재야. 예스.
다 했어?
아니 안 해. 이건 위에만 했어.
이거 어떻게 했냐?
아니 내가 얘기했잖아. 이걸 여기
우리 다
옮겨야 돼.
했는데.
왜냐면 여기가 맨 끝에는 옮기기가 좀 들어가기 힘드니까 엉지 여기 내리고 이제 그 순서대로 하면 돼. 봐봐.
Oh,
네.
you can eat.
아 근데 마스크. 이건 뭐?
떡.
떡. 너무 좋아요.
감.
꽃감 그
홍시.
좋아요.
Dried persimmon.
이라고 하나?
Dried persimmon. It is 떡.
스윗. 아 됐어. 나 승부를 이거 어떻게 됐어. 됐어. 나 2개 맞췄다. 나이스.
문제야 이거 있잖아.
됐잖아. 난 천재니까. 재수없다. 이거 어떡하지? 잘못했다.
와. 두 개나 맞췄네.
이거 좀. 이거 왜 좀 해주겠는데. 이럴 때. 야 뒤에 여기 바로 데려. 이거 위로 올라가면 되는데. 아니 억울하네.
잘한다.
오케이. 어떻게 했지? 이렇게 했어. 잠깐만 그러면 안 되는데.
얘를 좀 밀어봐. 4까지. 아까 그 상태에서.
그럼 이게 7이 계속 이쪽으로 가잖아. 아니
새롭게 해보면 되지. 이를 좀 보내고.
자 6이랑 4는 빠지자.
잘하다 미.
나 이거 진짜 어렸을 때 승부는 당해서 내가 꼭 이긴다. 이게
마지막 줄이 제일 어려워.
우리도 2개 남았어 지금.
강준이가 막 자기 안 하는데.
아.
How can you do last?
이거
다 망쳐야 되나?
이 망치기 새로 하고 있는 거였구나.
마지막 줄 옛날 어떻게 했어? 이거 이런 애는 그림이 있었는데.
이거 위에 좀 없애야 돼. 여기 3은 아래로 먼저 만들까?
뭔가 수학적인 계산.
Okay.
없어.
So,
그냥 그러니까
alright, keep going.
그래서 이렇게 된다고.
이제는 주고.
됐어.
Not quite.
제발. 됐었는데. 아니 내가 왜
Alright,
이렇게
so-
했지 처음에?
Yeah.
아,
What went wrong?
뒤집어야 되나 이거를?
뒤집고 싶다 진짜. 이판 오프. 이렇게 해보자. 아니 이렇게 오케이. 그러니까 이게 좀 뒤집었으면 좋겠는데 나도. 아니 티처.
Yeah.
아니 답답함.
Keep going a little more.
오 마이 갓. 안 돼요. 안 된다고요.
Okay, what's going wrong? What's the problem?
And the last time.
Yeah, what's the one problem?
하고
What
싶다.
does your board look like?
이거 됐어. 이거 봐. 여기 되는데 5만 없어지면 돼. 됐잖아. 잠깐만. 똑같잖아. 피니시. 여기까지. 여기까지. 야, 그럼 여기서부터 맞춰볼까? 여기가 6이 아니 7, 6, 5, 4가 있어야 되나? 4부터 맞춰보자 그러면. 4가 여기까지.
you have enough?
뭔가 하면 할수 있을 것 같은데.
야, 나도 그 느낌 완전 옛날에 완전 많이 받았는데 절대 안 됐었어. 4부터 해보자. 4부터. 여기 위로 올리면 되지? 4 다음에 여기다
3
써야
여기
되지.
있었는데.
3 다음에 5가 여기 써야겠지. 5가 여기 써야 돼. 아니지. 5래? 맞아. 그 다음 6. 됐지? 내 말 맞지? 쌤! 안 돼! 1, 2, 4! 왜? 아니, 이거 안 해도 되는데. 오케이. 어떻게 했지?
이거 바꾸고 싶다
그래.
no.
거꾸로 됐어. 뒤로 하야 되나?
트위터 헬프. 이거 노래.
아니, 이게.
여기 있잖아.
1, 2, 3, 4. 이 숫자 몰라요. 나도 알 수 있어.
잠깐만.
Okay.
진짜 이거 짜증나.
Okay, alright, yeah, you almost stop. Stop there.
Okay.
Stop there. What does your board look like? Alright, so what do you have?
오케이.
Tell me what to write.
Me?
Yeah. What's your board look like?
7, 6, 4, 5, 4, 2, 3, 1.
We are 1, 2, 3.
아까도 나왔어.
나도 그렇게 나왔었어. 그래가지고 좀.
I think this puzzle has no answer
Why?
because you can't solve it.
That's why? Okay, just because you can't solve it means there's no answer? Why is there no answer?
이런 건 엎어야지.
Okay, what's the difference between these two boards?
Best buy.
Namely? Hint.
들어서 빼요.
이거 참
Can you ever swap two?
No.
Think. Okay, let's think about our moves.
all move.
What possible moves can you make? You can go left, right,
Down,
up,
down.
down. Okay. How many squares do you move?
Oh, done.
어? 너?
No, you definitely didn't solve it. I can tell you that.
Huh? It is impossible.
It's impossible. Why? Well, you get cookie anyways.
아, 진짜.
I'm sorry. I wanted you to feel the frustration.
와.
네.
내가 뭐해?
아니, 그거는 이거
I can't open this.
아, 그러네.
한쪽으로 반대.
둘.
Oh my god, why is
네, 둘.
Ah. you so good? So strong. Let me try.
왜 혼자 바뀌냐고?
들어가자, 저거. 들어가자, 1 이렇게 했잖아.
응?
뭐가
그렇잖아.
응.
아니.
아니니.
여기서 칩 여러분.
Okay,
치료.
think.
Think?
Alright.
저 생각하고 있는데.
No. So, how many squares do you move when
아니
you go
하고
right?
있는 거.
3.
이거 된거 같잖아.
잠깐만.
1.
What?
Huh?
1 square.
네.
아.
How many squares do you move when you go left?
2.
응?
1.
아, 뭘.
1 square to the left.
준이야가 아닌 민주야가 아닌 준이야. 이렇게 됐어.
Or minus 1.
너무
Minus 1. So if we call forward this way, forward is going toward this one, and backwards is going toward there. So minus 1 in the x. Alright. Now, what happens? How many squares when you go down?
마이너스 1.
No, because, okay. So 4 goes down. 1. So it moves 1.
응?
그러니까
Alright, so it goes, alright, so this is, if you say it's, okay, this could be the y direction. So this is minus 1 in the y direction. Minus 1 down. And 1 up, right? Okay. Now, how many squares change when it comes down? So it goes ahead of how many?
1.
응?
2.
3?
3.
세 개 밀 수 있잖아.
It's passing 3 numbers. Okay. So, if I were to label these as place numbers, 1 through 16, right?
응.
What can it do? We can go plus 4, right?
Right.
So you can go from 12 to 8.
How we can do this? There is a
Alright, so this is minus 4, right? And then this is plus 4. 8 to 12. You see? Alright. Let's take a minute to think about it. What's happening?
Isn't it minus 3? Because we can move the square only 3. 3.
아니 그러니까 그 아래 갈수록 4씩 늘어나고 줄어든다는 거지 그냥 숫자.
아. 그럼
Okay. Alright, let's think about it. Let's think about it. Come on. I got it. I'm getting you a cookie.
오케이.
There's like one cookie. Okay. So, think about it. In one move, what changes?
8.
In one move, what can we do? What are our possible moves?
4.
So, if we write this as like x, y, so we write it as left, so we write this as sideways, like, we can write it as like, you know, x, y, where y is, you know, up and down, and x is side to side, right?
Yes.
So, what are our possible moves? Well, we have 1, and then 0 on the y. Okay. -1, 0.
0 and 1. 2 minus 1.
이거 돌려가는 거 아니야?
Alright, so what's true about every move?
One is true by every move.
Okay. We went from this, right? We went from this to this. Is it possible for us to swap these two?
No.
Why?
Because it is blocked by other block.
오!
와.
돌려가는 건데? 아니, teacher.
트위스트.
돌려가는
아니,
이거 돌려가는 거.
아니 근데 안 됐어요.
맞아. 근데 안 됐어.
안 됐어요.
Thank you.
아, thank you. Delicious.
너무 열심히 했냐?
Okay. So, let's think about it. I want you to think about how the board changes.
If you swap the 2 and 3, the other block will move another place.
Yeah, so we could go 1, you know, basically to get 3 and 2 swapped, you need to go down and then, you know, this goes. Okay, if we were to simultaneously swap these two, what kind of move would that be? Why does it not work in our given framework of moves? Alright, so for a number, we can jump ahead of 3 numbers, or we can go 1 ahead, or 1 behind. Go behind 3 numbers. This is supposed to be hard. Don't worry that you don't understand why yet. It's very difficult. But this was a actually famous problem, because sometimes, let me tell you, if I had written the board like this, you can solve it.
So that is this problem.
That one you can solve. Why? Okay. So we have 1 through 15, right? In this order. What's different about the 15 through 1? And the 1 through 15. Okay, so think about your possible moves. Like you're on a board, so you need to get, imagine that the squares are numbers, right?
Yes.
So imagine that the squares are actually just numbered 1 through 16, right? Right? And you could start with this, and you want to match the number to its own square. How many squares does each one have to move? What happens when you make a move?
6.
Yeah, so 1,
5.
so both 1 and 15 have to move 5, right? You have 15 numbers. Each number has to swap places with another number. Why is that no good? This is gonna be your homework, is to just think about it. Think about it.
What is
No, it's fun, you can try to solve it more.
what is
You can try to
question?
see which ones are solvable and which ones aren't solvable. Because you can shuffle the game a lot of different ways. And some of them are solvable and some of them aren't. And I want you to think about why that is. Okay?
What is question?
Okay. Play the game. And so when you shuffle, you always want to get to this result. Okay? This is your goal.
Start.
This is the end goal. End. This is finished. The start changes. Some of the starts, some configurations that you start in, you'll be able to win. And some, it's impossible. This one is impossible. This is impossible. However, if I were to, this would be possible.
So you have to think why that is possible or impossible.
Yeah, try some out and see.
Yeah.
I'm not going to tell you because I want you to think about it first. And that's part of the whole thing where if you don't think about it and I just tell you, you won't understand. You forget very fast. But you see it doesn't work, right? You tried it. You tried so much, it doesn't work. So you believe me.
Finish?
Yeah. Oh yeah, it's yeah. It's 4:40. And if you think that you figure out why, You can message in the chat.
Okay.
You can let people know.
Teacher, wait. Second picture is 2-3-1 or 3-2-1?
This is what you got. You went from this to this. This to this is impossible. You can try it. It's all on the thing that I sent.
Could you send link or another homework?
The link.
link? Okay.
Yeah, link. Oh no, we do more of this next time, but I can send the lecture with this problem. Because the answer to the problem is in the lecture. It's a very famous problem. So. But the lecture, it might be too hard because they prove it's impossible, like using math, and that's kind of hard, but understanding on a basic level is, you can do it. I don't know about proving because it's kind of hard to prove it.
이거 드셔도 되는데.
잠깐만요.
그만.
할 수 있는데.
Yeah, you can do it.
아니.
If it's
오 마이 갓.
if it's small, you
끝났지?
can do it.
없는 다 나간.